Okay, consider, here we go, we've got x and y here. Consider we've got the line y equals 3. Okay, y equals 3. That's this line. And we're going to consider it between x is 0 and x equals 5. Okay. Now, if I was to take this line and rotate it in 3D, so it comes out of the board and inside the board around, we'd get a cylinder, wouldn't we? We'd get this cylinder. I'll picture it down here. I'll draw a solid line. And it comes out this way, rotates around, goes back up there, goes round, back up, and we get this cylinder. Okay, what's the volume of that cylinder? Oh, well, let's just work it out the easy way. The volume of a cylinder, we know the volume has to equal pi r squared h. Okay, so the area of this surface here times by the height. So the area of this circle here is pi r squared. Now what's r? Now r is equal to 3. Okay, so which is equal to this y. Now this is important for a minute, so let's just remember that. Times 3 squared. Now what's the height? The height is the difference between 5 and 0, so that's just 5. So now I've got 9 pi times 5, I've done that in a weird way, 45 pi, there we go. And what are the units? Well, we don't know what these are, but they're going to be cubic units. Whatever the units are, got cubic units. So 45 pi cubic units. Okay, now we want to do this with in our function notation. So we're going to do this with calculus. Okay, so what have we got here? Now, with calculus, we can add up a bunch of small things. So here, we've got the function being rotated around creates this little cylinder. So a little tiny cylinder here, and then we're going to add them all up. So this little cylinder, we'll call this of height dx. Yeah, this is our dx. You know, this distance there. Okay, there's a little cylinder. Okay, little tiny cylinder. Now we can imagine these little tiny cylinders all the way along, and then we're going to add up their volume. So the volume of this little cylinder is going to be pi times r, which is our value of y. Okay, so we've got to have this little cylinder is just pi times y squared times dx. Okay, dx is like the height. Okay, dx is like the height. Our radius is our y. Okay, and times by pi. So that's this little cylinder, and then we want to add them all up as from 0 to 5. Okay, so we want to add them all up. So we're going to sum them from, what should I call this? Should I call this, oh yeah, from x equals 0 to x equals 5. Okay, but then we're going to make these little cylinders infinitely small. So we want the limit, okay, as this gets smaller and smaller. Okay, so limit as dx approaches 0. Okay, so as this approaches 0, gets smaller and smaller and smaller, what is this limit? Okay, now we've got a way of adding up these sums. It's called, we can take an integral. Okay, so this is the integral of pi from 0 to 5 y squared dx. And that's it. Okay, so we take the function, we square it, okay, and we multiply it by 5, and we take it as a definite integral between them there. Okay, so let's try it. Okay, so this y, the function of y here is just 3. So now I've got pi 0, 5, 3 squared dx. Okay, let's take that integral. We just get 9x, sorry. 9x between 0 and 5. So we get pi, 9 5s are 45, minus 0. We get 45 pi cubic units. Not a big surprise. We already knew the answer. Yeah. Okay. Let's do it with a different function. Okay. It gets much more interesting when we do it with different functions. Okay. So let's give that a go. Okay. Our first function, what do we want to try? Try x squared. Okay. So consider y equals x squared. Okay. Should we just draw a quick, we all know what x squared looks like. We'll just draw it really small here. X, y squared. Now we're going to look between 1 and 3. So we're going to take this area and rotate it around the x-axis. Okay, so that volume of revolution, rotate it, is between 1 and 3 of the function y squared. So we're going to go y squared dx, pardon me, equals 1 and 3. This is x squared squared, so this is x to the 4th dx, equals, okay, pi, let's do the integral. That's just 1/5 of x to the 5 between 1 and 3. So we get pi 1/5 of, oh, hang on, what do we get here? 1/5 of 3 to the 5, 3 to the 5, 3 to the 4 is 81. So times 3 is 243 minus x to the, yeah, it's just 1/5. Too much time thinking about that one. So what have I got? 242. Pi times 242 on 5 cubic units. That's cool. Work that out. All right. What if we wanted to rotate an area around the y-axis? Okay. So what we need to do then, very similar. Oh, I've got a croaky throat. Okay, very similar. Okay, there we go. We're going to rotate. What area are we going to rotate this time? We're going to rotate y equals 1 to 9. Okay. We're going to rotate from y equals 1 to y equals 9, and we're going to rotate it around this axis now. Okay. So it's the same idea. We're going to rotate between 1 and 9 pi, so this is the volume. Pardon me. Now we want to do x squared. Now x squared is just equal to y. We already know that. dy. Okay. So we've got, let's take the integral, y squared, 9 and 1, pi times 1/2 of 9 squared is 81, minus half of 1 squared, which is just half. So I get 80 on 2 pi, which is 40 pi cubic units. Done. Okay, that's it for this video.